Hey everybody, so it is Miss Cook here with y'all today, and we're going to talk about topic 2, which is area and perimeter of composite figures. Throughout this lesson, we will answer the following questions. What are composite figures? How do we calculate the perimeter of a composite figure? And how do we calculate the area of a composite figure? And then afterwards, we're going to talk about the assignment you'll have to complete. So what is a composite figure? Well, a composite figure is defined as a shape that can be divided into more than one shape. So let's say we start off with a rectangle. And with this rectangle, I want to attach half of a circle. Well, that might look something like this, which is a very common shape, a composite shape that you'll see. And this composite shape is actually composed of two different figures, which we just said was the rectangle and half of a circle. Typically, with composite figures, you're already given the full figure, and we're having to divide that figure into different shapes. So let's look at a few examples. So the first one, we have something that looks like a boot, and we can tell that this boot is all right, so we have a figure here that looks something like a boot. Well, it looks like it's composed of what looks like to be a rectangle and a triangle. So this figure is made up of a rectangle and a triangle. Gotta get rid of it. Oh, no. So let's look at our next one. You might also see a shape that looks like an arrow. And we can see that this arrow looks like it's part of a rectangle and a triangle. Well, you might also see something that looks like might be a heart. Well, it already has these dotted lines on here where it shows like this heart is made of two semicircles and a square. You might also see a shape that looks like a snow cone, which is just a triangle and a semicircle. Or you might also see shapes that might be a little more difficult. Well, at that point, you just kind of look at it eyeball, what type of shapes do I see in this? Well, I can see on my right side here that I have a rectangle right here. And I also see what looks like to be another rectangle right here. But then I have this figure down here that looks like a trapezoid. But a trapezoid could actually be broken into more than just one figure. I could make it look like a rectangle and a triangle. And this triangle specifically is a right triangle. So let's actually talk about taking the perimeter of a composite figure. So when we find the perimeter of a composite figure, we actually want to know what is the distance around the figure. So on this figure, I'm talking about these sides right here. This 5, my missing side, this 11, another missing side length, and another missing side length, 7 and 5. So I'm talking about these outside edges right here. So I guess the first thing I should probably do is to find the missing lengths. What is the missing length of this side? Well, I see that this here is a square. And I know for a square that all of my sides are the same measure. So that must mean that this side right here is also 5 meters. Well, then I know that this is 11 meters, but I need to figure out what this next side here is. Well, on a rectangle, we know that opposite sides are congruent. So if this is 7, then that must also mean that this side is 7. And now I need to figure out what this side down here is. Well, I don't exactly have an exact measurement at the moment, but I can figure it out based off of what my figure is giving me. So in my figure, I am told that this portion of the top of the rectangle is 11 meters, but I don't know what this portion is. But I could figure out what that portion is because this is a square, and we know that a square has nothing but 4 congruent sides. So that means that this here is also 5 meters. Well, if this length is 5 and if this length is 11, then can I just add them together and find out what this side is? So that must mean that this side is 5 plus 11, which is just 16. And my 11 looks kind of like a 4. Here, let me make that a little prettier. 11. Okay, so I'm just going to replace that saying that it's 16 right there. So the next thing that we need to do is we need to find what the actual perimeter is. And if you notice, I just made my 5 here disappear. But the reason why I did that is because my figure, when I'm talking about the perimeter, I'm talking about everything on the outside edges. And that 5 that was contained inside was inside my figure, not on the outside edges. So, yeah. So let's find the perimeter. We're going to add them all together. So we're going to say the perimeter is equal to 5 plus 5 plus 5 plus 11 plus 7 plus 16 and plus 7. And when you add them all together, you get that it's 56 meters. So I just want to write this in a form of a sentence. And I would just say that the perimeter of the figure is 56 meters. So let's actually try an example problem. So in this figure, it looks like I'm given an arrow. And we said that an arrow is pretty common, that we see them around. Well, let's count the sides of my figure and figure out what we do know. So I know right here on this top portion that I'm looking at. Let me color it in for y'all so y'all know where I'm looking at. So let's count this side right here. Well, I know that this is 1, 2, 3, 4, 5, 6. And this is actually counting in units because of the blocks. So I'm just going to say that this side is 6 units. And then I'm going to count what this side to my left is. Well, I can see that it is 1, 2, 3, 4. That's a total of 4 units. And then this length right here is 1, 2, 3, 4, 5, 6. So I also got 6 units right here. And then now I'm going to this little portion here that kind of dips down. And I'm going to use a different color to show. So I have 1 square here, so that's 1, 2. So that's only a total of 2 units. And then I'm looking at what looks like to be a diagonal. And we talked about diagonals, how we can't count the length of a diagonal, that we had to use 2 different ways to do it. But I'm going to circle right back to that in just a minute. So if this is a diagonal, I can't figure it out just yet. Can't count it. And I have a diagonal right here, which I also can't figure out just yet. But I have another portion right here that hasn't been counted. And it's a total of 1, 2 units as well. Well, let's talk about the diagonals now and how we can find out what they are. So we use 2 different ways. We use the distance formula, but with the distance formula, we needed coordinate points. And in this case, we have a grid, but no coordinate points. So I'm just going to push distance out of my mind and not even focus on it because I know I can't use it. But our other way that we used was the Pythagorean theorem. And with the Pythagorean theorem, I know I can just draw a right triangle on my figure here and make this diagonal my hypotenuse. And the hypotenuse, if you remember, is across from the right angle. So if I'm given a right triangle, I can count the sides of my triangle and then decide what my diagonal is using the formula. So let's count this side here. I have 1, 2, 3, 4. So that's a total of 4 units. And then again, I have another side that is 1, 2, 3, 4. So that's also 4 units. And then I'm just going to replace my diagonal with the letter C, just some type of variable to resemble what I'm talking about when I go into the Pythagorean theorem. So the Pythagorean theorem is c squared, which equals a squared plus b squared. A lot of times you see it where it says a squared plus b squared equals c squared, but in this case, I was solving for c. So I just put it on the left side of my equation instead of the right side, but either way works. If you want to do a squared plus b squared equals c squared, it's totally okay. So now that I have my formula, I'm just going to fill in what I know. I know that a and b are both 4 units. So c squared is equal to 4 squared plus 4 squared. And my 4 squared plus 4 squared, all of this together, I know that 4 squared is a total of 16. So if this is 16, so that must also mean that this is 16. And together, 16 plus 16, it makes, what was it, 30? 32? It's 32, yeah. So that actually equals 32. So let me write that real quick. All right, 32. All right, so if this c squared is equal to 32, well, really, I need to figure out, okay, so my c squared is equal to 32, but I'm really only looking to figure out what one of my c's are equal to. But how do I undo a squared? Well, to undo a squared, I can just take the square root of both sides. So the square root of c squared is equal to the square root of 4 squared plus 4 squared, which we said was just 32. So I'm actually taking the square root of 32 on my right side. And then I can just make it look a little cleaner. The square root of c squared is just c. And the square root of 32, I am going to keep. So again, let me prefix that. That is just 32. So I want to know what the square root of 32 is. Well, let's plug it in the calculator. When we take the square root of it, we get that c is equal to 5.7. So over here, I'm going to replace my c with 5.7 units because that is the measure of it. And now I can look at this other diagonal. Well, if I can't use a distance formula, I'll have to use the Pythagorean theorem as well. Well, let's draw a right triangle around it. So bam, we have our right triangle, but now let's count our sides. So our side measures are 1, 2, 3, 4. That's also 4. But what about this right here? It's 1, 2, 3, 4. Well, if this side and this side is 4, and on this top triangle that we looked at, we had 2 sides that were 4, well, wouldn't this diagonal just be the exact same measure of this diagonal? I think so. So I'm just going to say it's 5.7 units as well. And now I'm just going to take away my right triangles that I drew in these 4 units because if I'm finding the perimeter of this figure, I'm just talking about these diagonal pieces, not these right triangles that I added to the figure. So they're going to go away. And now let's find the perimeter. Well, the perimeter is just all the sides added together, which is 4 plus 6 plus 2 plus 5.7 plus 5.7 plus 2 plus 6. And when I add them together, I get about 29.4. And again, I'm just going to write it in a form of a sentence according to the problem. The perimeter of the figure is 29.4 units. Okay, so let's try another problem. So example problem number 2. It wants us to find the perimeter of the figure as well. Well, when I'm looking at this figure, I know that the perimeter includes this side plus this side plus this outer edge of this semicircle. But I don't know what the length of this semicircle is around it. But when we talk about circles, we talked about how the outer edge is called the circumference, which is also the perimeter of the circle. So I'm looking for this portion, but again, I just don't know how to find what just that portion of that semicircle is for the circumference, but I could just make it a full circle, can't I? Because the semicircle is just about half of the circle. So let's just make it a full circle. And I know that the diameter of my circle is 10 feet squared. And the circumference formula for a circle is just C equals pi times diameter. Well, if my diameter is 10, we're going to plug that in. And then I replace pi with 3.14 just because it's a rounded approximation of pi, and I like it. Well, let's plug it in the calculator and figure out what we get. So we get that my circumference is 31.4 feet. But that's the circumference of the entire circle, the perimeter, the outer edge. That's the length of the whole circle. But only I want to know, what is the length of half of this circle? Well, to do that, I'm just going to take the circumference and I'm just going to divide it by 2 because I only want to know what half of it really is. So my x, which is just this portion right here that I'm coloring in right now, is x, which is a semicircle. That's what x is equal to. So if x is equal to that, I can just say that it's my total circumference of the entire circle divided by 2, since I only want to know what half of that circle perimeter is. When we plug that into the calculator, we find out that x is just 15.7. So I'm just going to replace that all with my x and everything with 15.7 feet. So now I can find the perimeter of the figure because I have what the length of this side, the length of this side, and I have the length of this semicircle outer edge. So I can say that my perimeter is equal to 6 plus 8 plus 15.7. So let's talk about this 10 I just put an X mark on. The reason why I didn't add this 10 feet is because this 10 feet is talking about the distance inside here. And that's inside the figure. In the perimeter, we're just talking about the outer edges of the figure, not the inside. So that's why I canceled it. Okay, so when I add all that together, I get that my perimeter is equal to 29.7 feet. So I'm just going to write it in the form of a sentence once again. The perimeter of the figure is 29.7 feet. So let's try another problem. But this time in this problem, we're going to be missing a length. And the length that we're missing is this side of my figure, where my X is at. And I see that there are tick marks, but let's circle back to that. So it tells me if the perimeter of the figure is 48 inches, then what is the missing length? So let's go back to the missing side. I said that we had tick marks. But what do those tick marks mean? Well, in geometry, we said the tick marks mean that the two sides are congruent. So I can also say that this top side here is also X. So now I can set up an equation to solve for the missing side. So all of the outside edges is 15 plus this 10 plus this X plus this 6 plus this 7 plus this X. I am told that it is all equal to 48 inches. So I'm going to set it equal to 48 inches because of the statement. And now I'm just going to combine like terms on my right side of the equal sign. So 48 is equal to 38 plus 2x. And my 38, just to kind of recap again, that's this 7 plus this 6, this 10, and this 15. That is what the 38 is resembling, the measure of all those together. But I only need to know what is my missing length. So why don't we get rid of this 38 inches? And to do that, I can just subtract it from both sides. So then I'm left with 10 inches is equal to 2x. So that 10 inches is talking about this x plus this x. Well, if I just want to know what 1x is equal to, I'm just going to divide by 2. So 10 divided by 2 is when we'll get 5 inches. So the measure of this side is just 5 inches. So I can say it in a sentence once again. The missing side length is 5 inches. Well, now that we've talked about the parameter of a figure, let's talk about the area of the figure. But before we do that, we kind of need to know a few formulas. Well, we know that a composite figure is made up of more than just one figure. It can be composed of anything from a triangle to a half circle. With that in mind, let's talk about those formulas real quick. So here's the formula for a square, a rectangle, a parallelogram, a triangle, a trapezoid, and a circle. But there actually are 2 figures in here that's a composite figure. So let's look at the parallelogram. I see that this red line here, which just kind of chopped off this part here that looks like a triangle. But I could also chop off another triangle on it. So I'm given like a square and 2 triangles. So that's a composite figure. And then this trapezoid. Well, it looks like it cuts off what looks to be a triangle there. And I could cut off another triangle. So in reality, even though we know the formulas for the area of a parallelogram and a trapezoid, let's say we didn't remember them, we could still break those into 2 smaller type of figures that we do know the formula for. And then we can kind of see over here that's a triangle. It has a line and it looks like it cuts the triangle into 2 right triangles. Well, in all reality, my triangle can be composed of 2 other triangles. So we still need that formula for the triangle, but we really don't need the formula for the trapezoid and the parallelogram if we can just cut them into basic shapes, such as a square, rectangle, or the triangle. So I'm just going to X them out. You don't have to X them out on your paper. They're good formulas to know anyway, but just in case. And then the circle. Well, I said over here that we have anything from a half circle in our figures, but I know that we don't have a formula written for it on here, so I'm just going to write a formula. So a half circle, pretend this is a half circle, y'all. Doesn't really look like one, but it's pretty anyway. Its area is just going to be equal to the total area of a circle, which is pi times r squared. And since a semicircle is only half of a circle, then I only want to know what half of that area is. So I can just say that's all of that divided by 2. So a half circle, its area is equal to pi times radius squared divided by 2. Okay, so let's actually do some practice problems. Well, actually, I guess we should probably talk about it, shouldn't we? So the area of composite figures. To find the area of composite figure, we're going to start with the whole shape. And we're going to break those shapes into its basic, we're going to break that figure into its basic shapes. Whether it's a circle, a half circle, a square, rectangle, a triangle, anything. So over here to the right, it looks like we have a half circle and a rectangle. And then for step 2, it tells us that we need to find the area of each shape. So if you look over here to the right, it tells you the area of the half circle, which is a is equal to pi times r squared divided by 2. And they plugged it in the information. This is what they got. And then they found the area of the rectangle. But it's kind of worded weird. It says area is equal to length times breadth. Breadth is just width. So I'm just going to put a W there just so we don't get confused. So that is just supposed to be a W. Length times width. That's all that means. Well, step 3, after you find the area of each of the shapes, you're going to add all of the shapes together and find the total sum. And so they did the half circle, which was 24.5.3 plus 500. Now let's actually try some example problems because, I was just trying to jump ahead earlier. But so example 4. We're told to find the area of the given figure. Well, it looks like we're already given a triangle and a rectangle inside this figure. But before we can find the area of the figure, So let's start off with breaking it in two pieces. So again, there's a triangle and a rectangle, but let's look at this triangle. Well, on a triangle, we know that the area formula is just area is equal to base times height divided by 2. Well, let's see if I actually have that information. So it looks like that I don't have my height and I don't have my base. So it kind of looks confusing a little where I have this 13 here and it looks like it is the height of my triangle, but actually it's talking about this line right here. My 13 centimeters is the total length of this entire side of the figure. So I'm just going to scribble out this 13 here so it doesn't get us confused. All right, it's gone. So when I'm looking at the height of my triangle, I'm talking about only this portion. But I'm given what the total length of this entire side. And I need to find out how much this side right here is so I can figure out what's left over here. So this, I can actually figure that out from a rectangle. So if this side is 7, then that must also mean that this side here is also 7. So I'm just going to subtract the difference of my heights, the total height minus the portion that I don't want, which was the 7. So if I do 13 minus 7, I am given that my height is 6 centimeters. But what is my base? I know my height, but not my base. Well, I'm going to do the same thing, just like I did with the height. I know that I am looking for this portion. But with this portion, it's connected to this portion right here. So this is one side of my rectangle, but I know that the length of my rectangle is given to me as 16. So that means this entire portion is also 16. So I'm just going to take the difference from my lengths here. I'm going to say 16 minus 8. 16 is the total length, and 8 is the portion that I don't want. So I got 16 minus 8, which is just 8 centimeters, is my base. So now I can finally find the area of my triangle by saying it's equal to base times height divided by 2. I'm going to plug in my information, which is 6 times 8 divided by 2. And then I'm going to simplify it, which is 24 centimeters squared. Now that I know the area of my triangle, now I can find the area of my rectangle. The area of my rectangle, we know, is length times width. And we already have that information, so let's just go ahead and plug it in. And now we can simplify it. And so my area is equal to 112 centimeters squared. Well, if we look back to the problem, it tells us to find the area of the given figure. And our given figure is this rectangle plus this triangle. So my total area is going to be the two of those combined, which is just the sum. So 24 centimeters squared plus 112 centimeters squared. And when we simplify that, we get that the area is 136 centimeters squared. So I'm just going to write that in a sentence once again. The area, the total area of the figure is 136 centimeters squared. Okay, so let's try another problem. So example 5, we're told to find the area of the given figure. And we're going to start off the figure we basically looked at in the very beginning, which was a rectangle and a semicircle. So we need to break this figure into two different ones. We need to find the area of the semicircle and find the area of the rectangle. Let's start with the rectangle, just because I think that's super sweet and easy. So the area is length times width. Well, we're given that 15 is the length and 10 is the width. And then let's just simplify that. So 10 times 15 gives you that the area of the rectangle is just 150 inches squared. Well, now that we know the rectangle, we want to know what the semicircle is. And if you remember, when we were talking about the formulas, I gave you a formula for that, which is just pi times r squared divided by 2. Well, my R resembles my radius, but I'm only given what the diameter is, which is 10. So if we just recall real quick, the radius is half the size of the diameter. So the radius, if I cut this diameter in half, this portion and this portion is both 5. So the radius must be 5 inches. So with that being said, let's plug in 5 for our radius. So my area is equal to 3.14 times 5 squared, and that's divided by 2. And then let's approximate that, and we get that the area is 39.25 inches squared. Well, now that I know the area of my rectangle and the area of my semicircle, I can find the area of the composite figure, which is just the rectangle plus the half circle. So plugging in that information, I'm given that the area of the entire figure is 189.25 inches squared. And just once again, because I love sentences, I'm just going to say the total area of the figure is 189.25 inches squared. So let's look at another area problem, but this time we're going to be missing a length. So it tells us that the area of the figure is 55 centimeters squared, and it wants to know what the missing length is. Well, I know that this entire area of the figure is 55. That's the total area. And my missing length looks like it's the base of this triangle here. But before I can do that, let's just talk about the area of the rectangle since I have its dimensions. Well, the area of the rectangle we know is length times width. When I plug in my information, I am given that the area is 30 centimeters squared. Well, this is just 30 centimeters squared, but the entire figure is 55 centimeters squared. So if I was just to remove this rectangle away from my figure, how much area would be left over for my triangle? Well, I can simply just do that by taking the area is equal to the entire figure minus the rectangle's area. So that would be 55 minus 30. And 55 minus 30 we're left with is 25 centimeters squared. So my triangle is 25 centimeters squared is the area. And now let's try solving for the base. Well, if the area formula for a triangle is half times base times height, then let's figure out what we know in this. My area we know is 25 centimeters squared. And then we have 1/2 times base. We do not know what the base is because that's the piece that we're looking for. But our height we do know because of this rectangle. Since this side is 5, that must mean that this side is also 5. So let's just plug in the information that we have. We have 25 is equal to 1/2 times base times 5. Well, I'm just going to make this a little cleaner and easier for us to see. So I can use commutative property, where I can basically say that 1/2 times 5 times b, which is the same thing as 1/2 times base times 5 because of commutative property. And because of that, I'm going to simplify 1/2 times 5. So what is half of 5? Half of 5 is just 2.5. So I have 25 is equal to 2.5 times b. Well, I just want to know what 1b is equal to, so I'm going to divide both sides by 2.5. And when I simplify 25 divided by 2.5, I'm given that my base is equal to 10 centimeters. So once again, another sentence, here we go. The missing length of the figure is 10 centimeters. All right, so now let's talk about your homework. So for your homework, you're going to go to It's Learning. And on It's Learning, you're going to hit on your plans. And in your plans, you're going to see something that looks like this. And on the right side, it tells you like topic 1, handout, homework, your lesson, your guided notes, and then here it is, homework, topic 2. is your assignment. You're going to click on it, and then you're just going to start it. And it's just 12 questions. And I hope y'all enjoyed this video, and I hope y'all have a great day. Bye.